Hey, welcome back to my channel. So today I'll be looking at this power supply. This is HP power supply. So let's have a look together and see what's wrong with it. Okay, so let's first open it. Okay, so we are in. Let's now see what's wrong with this power supply. So as you can see, we have the mains power comes from this connector over here, then goes through these filters and then arrive to this bridge rectifier. Here we have a fuse that we need to check. After the bridge rectifier, it goes to this capacitor, the big capacitor, as DC, 340 volts. Yeah, and then after this capacitor, it goes through these MOSFETs, and it will be again converted as AC, but with high frequency, and to be driven to drive this transformer. After this transformer, it goes through this rectifier again, diode or a MOSFET, two of them, mostly diodes. These will convert it back to DC, and then here we have the output goes through these wires. Okay, so we need to check first the input circuit. If the input circuit is good, then we need to check the output circuit. I have to get the PCB out here in order for us to have access for all these components. Let's take this ground. Okay, I think now we can take it out. We need to measure this capacitor if it does have voltage. It doesn't, 0 volts, so it doesn't have anything. So now we can test. First thing we will test is the fuse, which is somewhere here. The fuse is here, so we can test it. Yeah, the fuse is good. As you can see, we have 0 ohms. You see, we have a good fuse. Then we need to check the bridge rectifier, which is this. Let me put it like this. Okay, so the bridge rectifier is these 4 pins. The inner pins are the AC side, which is good, as I can see, is not shorted, and the outer pins are the DC side, and also we have no short. Let's go to diode mode. So if we put one probe to, let's say, this pin and measure the inner pins, we get 0.4, 0.4, which indicate that we have the ground side here. This is the ground side, and the bridge rectifier is good. Now if we put the black probe here and we measure the inner pins, the AC side, we have 0.4 and 0.4. That means this is the positive side. Also, we can trace these lines back to this transformer, capacitor, the big one. Then we can also know which one is which. So if we check this to this is 0.3, this one to this is not connected. So if we measure this to this, 0.8, this one to this is shorted, so this is the ground. As I said, this is the ground. Normally the positive will go through the diodes, MOSFETs, that's why it's not connected directly. Yeah, we have 0.378. now if we test these MOSFETs, two are here and two are there. So if we test them, this one is actually a diode with two pins, 0.3, which is good. This one, 0.5, 0.4, also a good one. Yeah. Now if we go and test the other two transistors, they are here. One is this one, I think. Let's have a look again. Yeah, this one is the first one, and we have no short. These two are shorted together because of this resistor over here. Okay, so the other one is so the other one is this one here, 0.4, 0.4, and these two should read almost 0 because of this resistor again. Yeah, this resistor, as you can see, between these two pins. Yeah, and also this one have these two resistors across this two pins. Yeah, so now we know that we have no short in the primary side, so it must be in the secondary side, or we have, for example, a bad optocoupler that prevented this power supply from working. So let's test the DC side, which is the output side. If we test the ground pin with the 12-volt line, so this is the 12-volt, the yellow one, with the ground, which is the black, it is not shorted. This is because of the capacitors. Yeah, and if we test the standby 5-volt, the purple one, to ground, the same, it is good. The minus 12-volt, the blue line, the same, it is good. So if we test these wires, we have here a gray wire, a green wire, white wire, and red and white. I don't think that they will go short. These wires will go short. So if I put one to ground and measure these, no short, no short, nothing, no short. Yeah, so it is not shorted. no short at all. But we should test these two rectifiers over here, the diodes. Sometimes one is diode, the other is MOSFET. Let's see what we have. They are in which one? This one. They are here. They both are transistors or a dual diode in one package. .4. This is not shorted. 0.4, 1.3. They are not shorted. Both of them are not shorted. So I think we might need to give it a power and see what's wrong with this one. Let's put it back and see what's wrong with this power supply. Two is enough? I think they are enough. Let's put one is here, one in this corner. Yeah, okay, let's test it through a series lamp. Okay, let me put the series lamp on. Okay, as you can see, we have the series lamp over there. Let's now connect the power. Let's put the ground. Okay, let's turn on and see if it will work. As you can see, we have a flash. That is a good indication. That flash means that we don't have a short in the primary side. Now if we go to voltage mode and test and see if we do have voltage in this connector. So ground and 12 volt, we have nothing. So it is not switching. Nothing wrong, but it is not switching. Let's test the other pins. So this one is the standby voltage, nothing. This is the -12, nothing. What about this one? So this one has nothing. This the green one, also nothing. White, red, white, white, red, they all have nothing. So we don't have output anywhere. Yeah, so there is still a problem in this power supply, but it is not a short. So we need to find the culprit, the cause of this problem. In this total board we have these potentiometers. I think this is as a feedback circuit and a power on circuit. So this connector is all connected to this total board, and the fan connector also connected to this board, and these both are in the also on this board. And also here we have a temperature sensor connected to this heatsink, and all its wires goes also to this board. Yeah, so we have something wrong, maybe in this circuit board or maybe in the switching circuit. Let's have a look and see if we have voltage on this. I think I spot something. Let's take the power off. I will disconnect the power from there. Okay, so let me turn on the microscope so you can see it. Microscope. Okay, so we are in the microscope. If we go to the power supply, look at this. Look at this. This is a resistor and it's totally burned. Yeah, this is, I think, what provides the voltage, the VCC voltage, to the switching IC, which is this one, TNY279. So this IC might be faulty, might be shorted. Now we need to take the whole board again and discharge the big capacitor, this one, and see what's the problem with this circuit over here. Yeah, we need to test this diode and we need to test this switching IC. So let's go back to main camera. Let me take that lamp off. Yeah, so let's take the board out again. Now we need to be careful not to short the pins of this capacitor. So okay, if we test the voltage on that capacitor now, we have how much? It's this one. We have 230 volts. You can see, so it is very dangerous. Let's use this discharging tool. You will see this lamp lighting up while discharging this capacitor. You see it? It will not take a long time, so I think it is discharged. Let's test again. We have 2 volts, so it is safe to touch it right now. Let's short these pins, take everything out, so now it is safe to touch it. Okay, so let's inspect this circuit over here. Yeah, let me take this white thingy out. Okay, so let's measure the pins of this switching IC. Okay, if we go to diode mode again, and test the source with the drain, we have short. What about these pins over here, everything is shorted. So we need to change both the IC, this IC, the switching IC, and that resistor. I will check again this diode once I take that switching IC off the board. So now let's put low melt solder. The resistor is this one. I think this is a low value resistor. It works as a fuse to protect this MOSFET, or I mean switching IC. This switching IC actually have a MOSFET inside it, so it is used to drive the transformer. So I will apply a low melt solder to this resistor and to the switching IC. First, let's take that resistor out, if we can read its color code. So here is the resistor. Its colors is black, gold, gold. Or is it from this side? Yeah, from this side it is brown, black, gold, gold. So it is, I think it is 1.0, or it is 0.1. So it is a low value resistor. This is a 1/4 watt resistor. I will see if I have that resistor. I think I have it. So now let's take this switching IC and test this diode. Then okay, so it is out. Yeah, let's clean these holes. Okay, I think it is clean enough. Let me just take this flux off the board. Okay, so let's find out what the value of this resistor, and we can change this switching IC also. But first let's test that diode, if it is good or not. So the diode is here. The diode is good. We have another 2 diodes here, but they will, I think, show as short, or they are, no, they are good. I thought they will show as short because they are connected to this transformer over here. Yeah, So let's now change these two components and hope this power supply will come back to life again. Okay, so I don't have this TNY279PG, but I have others. Let's see what I have. If I go to desktop and I open my inventory, spares inventory, it is already open, yes. Can see? I think you can. So as you can see here, I have TNY 290PG, 288PG, 280PN, and 277PN. If I open this one, the datasheet of this one, we got this datasheet. As you can see, where does it go? Yeah, okay, we can see. So as you can see, this table over here, the one I have is 279PG, this one. I mean this one, the one we have is the TNY 279PG, but the one I have is 280PG. I think the PN or PG doesn't mean anything. Yeah, so the original one, the faulty one, this one is 18 watt. The one I have 280 is 20 watts, so the one I have is much better, so we will put this one. Yeah, let's go and take it. So this one is at position A6. Okay, now I'll go to position A6 and bring that IC. So this is the position A6, this is the package I use, this is A6, this one for example A7, the one before it A5, and that's it. That is how I store my spares. So now I have these. This is different, this is different, this one is 288, this one, this is different, this is different, this one is 277. Yeah, the 277 is how much? Is 13 watt, so it is lower than this one. This one is 18 watt, this one is 13 watt. It will work if we put it, but it will get damaged pretty sooner. This one is 280, so we will put this one. I think I have others. This is SMD. This is different. This one is TNY 290, so this is even more powerful, and this is different. Yeah, so we'll take one from this bag and we will put it. We still need that resistor. Let me check that resistor. So what I found is only this 1 watt, 1 ohm, but it is very big in comparison with this one. Yeah, I think I can use this one. This is a half watt, but this one is a 2.2 ohms. Let's see if we have more than one value over there. No, it is all 2.2 ohms. I think this will work. 1.2 ohm will not make a big difference. Let's put this one and see if it doesn't work. I will put this one just to test it. If it does work, then I will have to find a smaller one, a smaller wattage resistor. Before I get to what the mic. Okay, so for now let's put this 2.2 ohms resistor. Its color code is red, red, gold, gold. The original one was brown, black, gold, gold, just like this one. Brown, black, gold, gold, which is 1 ohm. Yeah. So let's put this resistor and this IC for now and see if it will work. Okay. Okay. So the switching IC is on. Let's put this resistor in and see what will happen. Okay, so that is the switching IC and the resistor. Let's solder them and test. Okay, so they are in, and now we can test, I think. Okay, so let's put it back again and see if anything will pop up. Okay, I think we are ready to test. Let's connect the power cord and again through the series lamp. Okay, so let's turn on and hope for the best. Okay, so the lamp flashed again. Well, that is a good sign again. Let's now test and see what voltages do we have at the output. So if we test the yellow lines, which are the 12-volt lines we still have nothing. Do you believe it? Do we need to turn on this power supply? Yeah, I think we need to turn on this power. So let's test the standby voltage, 5 volt. Also nothing. Minus 12, nothing. What about this connector here? The green line should have something at least, so we can turn it on. Nothing at all. So we still have something wrong in this power supply. Let me test the voltage at that resistor. We need a ground. Here we have 334 and also there, so the voltage has arrived to this IC. So why it isn't starting? That is a good question. That is a good question. Yeah, so we need to test the feedback circuit. Maybe the feedback circuit is also faulty. There is two optocouplers there that isolate this circuit from this. So these transformers also work as isolation between the switching circuit, the driving circuit, and the transistors. So there is still something wrong in this power supply and we need to find out. Okay, what IC is this one? This is CM6502SX. Let me search about that and see its VCC pin so we can test its voltage. So that IC is a BFC controller, this one. So if we test pin 11, which is the VCC, to pin 8, which is ground, we should see something. Yeah, so this is pin 8 and 9, 10, 11. We have nothing at all, so we don't have voltage coming to this PFC controller. Yeah, so let me find out the VCC pin. VCC positive supply, its minimum and maximum voltage is 10 volt to 18 volts. We should see around 15 volts at this power supply, but we don't have anything on this controller. So pin 8, 9, 10, 11, nothing at all. Let's inspect this circuitry again and see what's wrong with this circuit. Yeah, now we need to take this board again out. If we test the voltages, the voltage across that capacitor, we should see 312, so it is very dangerous. That's it. Let's test again. 5 volt, shorting out the probes and nothing. Okay, now we can touch it. Let's inspect again this BFC controller. This BFC controller is getting its voltage at pin 11, as we said. So pin 11 is at this side, so this is 8 ground, 9, 10, 11. So the pin 11 is coming through this resistor, and then through this another resistor, and then through this diode, I think. Let's test this diode, because this diode is connected to the IC that we replaced this one, so there might be something wrong with this resistors. If we test these resistors first, this one is 100, so it should be 10 ohm. It is. The other one is, I can't see it. Let's go under the microscope. So it is, which one? This one. It is 101, so it should be 1000, so it should be 1K, and we are reading 1K. Yeah, so then this is connected through this diode, and this diode is connected here. I think, is it connected there? If we test from here to here, it is connected there. Yeah, so we need to check this diode. The diode is good. The diode is good. This one, that is good. What about this transistor here? 0.5. Yeah, so this stand is pretty shaky, I think, because it's too long. So the voltage from pin 11 should arrive from this resistor. I can't see it. So this is pin 11. If we go this way, this is pin 8, 9, 10, 11. So this is 11, goes through here, then from here to here, and then from here to here, I think. Yes, but this one also going there and going here. This is not looking good resistor, or is it? This is a 0.1 ohm resistor. Ohms. We have 100 ohms. 01A. I think this is good. What about this 0 ohm resistor? This is good. What about this one? 32P. 1.9. I think this is good. What about these resistors here? So these resistors are in series, so these I think what provides power, initial power from this pin. Yeah, from this pin. Let's go to the camera so you can see. So this series resistor over here, I don't think we can see them, but we have 1, 2, 3, 4 resistors. They are all in series, and they are, I think, in the mega ohm range. If we test one of them, let's say this one, it should read in the mega ohm range. I don't know why it is not reading. It's fluctuating. This one reads 0.2 mega, and this one 0.2. So we have 1, 2, 3, 4 resistors coming from after this resistor that we replaced. So we should see some voltage across these resistors, I mean to ground. This provides the initial power for this to start. where does this go? Let's go to continuity. After the last resistor, where does it go? So it goes to this, yeah, it goes to these two optocouplers over here. So I don't think these are used as initial startup resistors, but most of the time when I see resistors like these, for example here, are used as initial startup resistors for the switching ICs. Then when the switching IC starts, it can provide its own voltage through the output, yeah, through the auxiliary voltage. So let's see what's wrong here. So we said that this goes to this optocoupler. This optocoupler is, the other pin is connected to this transformer, and from this side we have, do we have a good optocoupler? 0.6, 0.6. Nothing. 1 ohm, 1 volt voltage drop. Let me check and I will come back to you. Okay, so I've been testing everything. I couldn't find anything, so I decided to change this optocoupler, but I think it's a little bit discolored. Let's take it out and see. I brought this one. It's a different number, but I think it's the same. It will do the job. Yeah. So let's take this one. I will use low melt solder. Which one it is? Yeah, this one. Okay, so it is out. Let me wick off the old solder and the low melt solder. Okay. So let's install this one and see if it will work or not. Okay. If we test this in diode mode, one side should read 1 voltage drop, the other side should read nothing. Let's test this one. Here we have nothing, and the opposite way, 1 voltage drop, 1 volt. the other side is nothing. So it does read okay, but let's try it with the one that we replaced and hope it works. Yeah, so let me bring it paper. Okay, let's connect the power. It is turned on, the lamp is turned on, the lamp flashed. Let's measure now. Do we have voltage? We still have nothing, absolutely nothing. Still the same. Yeah, so I don't know actually what's wrong with this one. I don't know why it isn't switching. It is not trying to switch at all. I will try and do some more measurements and see what's wrong with it. If I find something, I will come back to you. Okay, so here is what I did. I have decided to replace this switching IC once again, because I said this might be faulty by from the manufacturer, so I decided to replace it. And now if I connect the power, the lamp flashed, and if we test the voltage at the yellow line, we have nothing. The minus 12 volt, absolutely nothing. And the purple one, we have 11.4. So now it's working. If we test the green wire to ground, we have how much? 5 volts, yes. So it is good now, it is working. I will install it and then I will test it, okay? I will short the green wire to ground and see if it will work. Just let me install it. I disconnected the power. Now I need to again discharge the capacitor. Okay, it is discharged, safe to touch. Now let's install it. Okay, now let's test. Let's connect the power again. Okay, the power is connected. Let's test again this one with this one. We have 11 volts, so it's still working. If we short the ground and the green one, and yes, it is working. It is working, yeah. So let's test again. Yes, it is working. Do we have 12 volts? Let's measure. Yes, we do have 12 volt. Let me just bring a jumper wire to keep it turned on. Okay. And the green wire, which is this one. It is good, it is working. Yeah, so if we test now this socket, for example, black and brown should have 12. Yes, we do have 12. And the green one, I mean the yellow one, we have 12. The black, I mean the purple, we have also 11.4, and the blue one we should have -12. Yes, so it is working. We finally fixed this power supply, so it is fixed. And the problem is this resistor and this IC only, not the optocoupler. And this one is actually also faulty, the one I used before. So this is the power supply, it's working again. Thank you for watching, and I hope I can see you in another video. Thank you so much.